Hello students, in the last video we have discussed dynamic programming. Now we are going to discuss about the steps to design dynamic programming algorithm can be also taken as a control abstraction for dynamic programming. Also we'll be discussing the applications of dynamic programming. Then we'll have a detailed study about optimal matrix multiplication. Let us check the step of dynamic programming algorithm. First one is to characterize the optimal substructure, then recursively define the value of an optimal solution, compute the value of bottom up, and if necessary, construct an optimal solution. Now what are the applications? It is used in metric chain multiplication, optimal binary search tree, and all pair shortest path algorithm. The application of a dynamic programming. First, the application I told us optimal matrix multiplication, and this is the main application of our dynamic programming. So I'll explain what is optimal matrix multiplication. As you know that the matrix multiplication is associative. The most efficient way to multiply a matrix together is found from optimal matrix multiplication. Suppose that you have given three matrices A1, A2 and A3. The order of A is 10 into 100. Order of A1 is equal to 10 into 100. Order of A2 is 100 into 5. Order of A3 is 5 into 50. Now you have to check whether A1, A2 together you multiply, thereafter you multiply A3, or you will check whether A2 and A3 is multiplied together and after that you multiplied with A1. Which one is better? For this we have to check how many scalar multiplications are required. So that I will explain how with a small example of 2 by 2 matrix. So A, B, C, D is the elements of the first matrix. E, F, G, H is the element of the second matrix. It is an order of 2 cross 2. Okay. So how many scalar multiplications will be required? So A into E plus B into G. So how many multiplication has come? 2 multiplication. Similarly here also we will have 2 multiplication. Here 2, here 2. So together there will be 8 scalar multiplication required to multiply these two matrices. That is 2 into 2, it's the order of this matrix. 2 into 2 is the order of the second matrix, and this middle 2 into 2, that will be considered as 1, 2. Okay, but 2 into 2 into 2, that is equal to 8. So similarly you can do here. That is A1 and A2. What is A1? 10 into 100. A2 100 into 5. 10 into 100 into 5. So that is 5000. Now what will be the order of A1 into A2? Order will be 10 into 5. That you already know how to write the order and all. You might have studied in mathematics. So A3 is equal to 5 into 50. So now this order is 10 into 5 and this order is 5 into 50. Now how can you write it? That is 10 into 5 into 50. You add them together, 5000 and 2500, you will get 7500. This 7500 scalar multiplications are required to multiply if you write it like this. And what about this? A1 alone, A2 and A3 are together. So let us write this first. Okay, this side. So what will be this? This will be 100 into 5, its order, it's 5 into 50. Together you can write 100 into 5 into 50. So the order will be 100 into 50. Here A1 order is 10 into 100. So how can you write this? 10 into 100 into 50. So that is 50,000. And what is the answer for this? 25,000. So answer will be 75,000. So 75,000 scalar multiplications are required. So which one is better now? This one or this one? This takes only 7,500 scalar multiplication. This one takes 75,000. So we know that the multiplication requires more time. So which one you will take? the first one you'll take. Okay, this is how the optimal matrix multiplication is